this is another set of waveform. Again, all these waveforms are cosine signal. Again, starting with the red one waveform. Again, if you go through, it will be starting from this point and it completes its one particular cycle. It completes its one particular cycle here. So its time period is 0 to 2 pi, and that is represented by cos theta because it is a cosine function. Then go for the blue one. This blue waveform starting from again same point, completes its first cycle here. Again from this point it completes its second cycle here. Okay. So within that 2 pi zone, it's complete 2 cycles. Its time period is, that means, half of that. So its frequency of that particular blue color waveform is 2 times with respect to the previous one, red color waveform. Third one, the green one, this green one waveform, in that case its time period, first time period is starting from again this point to that point, first cycle, then that point to this point, second cycle, and then this point to this point, third cycle. So within the same time zone, it completes its 3 cycle. So its time period is 1/3 of the red waveform. So its frequency will be 3 times than the first waveform. So again, this cosine waveform having this one, the fundamental frequency, this one known as first harmonics, and this one known as second harmonics, this one the third harmonics. Okay, so these are the different harmonics component of these waveform signal. Now if you have a Fourier series representation, that Fourier series representation is represented like this, having a DC component, having a cosine component or cosine series of cosine component and series of sine component, or we can say a series of even term as well as series of odd term having different harmonics component, To have what are the harmonics component available with these function, this f of t function, to identify that we need to find out the corresponding coefficient value for a particular function f of t. We need to find out the value of a0, find out the value of an, find out the value of bn, this coefficient value. To find out this coefficient value, these are the different formulas, or these are the different equations. By using these equations, we can able to determine the component value. DC component means when the value of a0 function is integrated with this kind of function 2 by t 0 to t f of t dt. By integrating that, if you get certain value, that is the DC component, which is represented by a0 term, a0 coefficient. To find out the cosine terms available for any function, we need to integrate and find out the value of n by this kind of expression, that is 2 by t 0 to t f of t cos n omega t dt, where the value of n can be any positive integer value. Similarly, bn also can be represented 2 by t 0 to t ft sin n omega t n equals to 1 to infinity in value. Okay.